All right. Hey, good morning. Today, guys, we're going to do more examples, more exercises on how to calculate percent composition. Remember, percent composition is the second to the last topic, okay, before we have our test on the mole. All right. So let's just jump into it, okay? So, for example, what is the percent composition of C6H12O6, which is your glucose, all right? So there's actually just two steps, okay? The first one is calculate the molar mass. And how do you do that again? You multiply the number of atoms by the atomic mass of each element, find the subtotal, and then you add them all up. So, for example, if you look at this carbon, there's 6 carbons, right? So you multiply that by the atomic mass of carbon, which is 12, okay? And then you get 72. It's the 72 that is actually important here, okay? That's your subtotal, right? So you do exactly the same way for each element, okay? So hydrogen, there's 12. Atomic mass of hydrogen is 1. So 12 times 1, you get 12, all right? Then oxygen, you got 6 multiplied by atomic mass, which is 16, and you get 96. Now, what do you do with all those three? You add them all up. This is your molar mass, okay? Or sometimes we just call it the the grand total, all right? So yeah, in some of our notes, you might have written it down there as the grand total, right? So subtotals and the molar mass or the grand total is the most important thing. So step two, okay, would be looking for each percent composition for each element is you divide the subtotal, okay, by the total molar mass or the grand total. So in our case, if you look closely, the subtotal for carbon is 72. So it's going to be 72 divided by our molar mass, which is 180, all right? Then multiplied by 100, you get 40%, okay? All right, and you do it exactly the same thing for each element. So again, the subtotal for hydrogen was 12, and I divide by 180, and then multiplied by 100, I get 6.66. Okay, don't forget to add the percent sign, and there you go. Oxygen, 96 divided by 180 times 100, you get 53.33%. Remember, guys, when you add all of these up, it should equals to 100 because it's like looking at a pie chart, okay? Where 40%, okay, about 40% of the substance is carbon, okay, that's your 40% right there, okay, and then about 50 something percent would be oxygen. So there's oxygen right here, that's 53.33%. And then finally you got your hydrogen right here. This would make up 6.66%. So again, it's like looking at a pie chart. Okay, so we're just looking at the components of the compound. All right. So go ahead. Hopefully you looked at this one right here. Go ahead. Let's look at the second example. I want you to pause this video and do this example right here. All right. Okay, very good. So let's try to do it together. So again, what is the percent composition of CO2? Again, step one is find the molar mass. So first of all, we need to count the elements. Carbon, oxygen. How many carbons do I have in CO2? 1. I multiplied by the atomic mass, which is 12, and I get 12. How many oxygens do I have? 2. Multiplied by the mass, which is 16, 32. And then you add these two up, you get 44. See it? Now we can do step 2. Step 2, you divide the subtotal for each one, divide by the total, multiply by 100. So percent C would be 12 divided by 44 times 100. Okay, and what would be that answer right there? It would be 27.3%. Okay, and this is C. Remember, guys, they should add up to 100. So actually, you don't even have to calculate for O, and you should be able to tell me that O is 72.7%. And how did I get that 72.7%? Again, remember, when you add these two up, it should equals to 100. So you can just get 100, subtract 27.3 from it, and you get 72.7. But if you wanted to calculate it, it still follows the exact same way. Subtotal, which is 32, divided by our total, which is 44, then multiply by 100, and you should get 72.77 right there. All right, very good. So that's if you're given a formula. Now, what if you're not given a formula, right? So what if you're not given a formula? All right, let's try to look at the next problem right here. So a chemist determined that should be a D, determined that 1.26 grams of iron reacts with 0.54 grams of oxygen to form rust. What is the percent composition of each element in the new compound? So we're looking at rust. So what is the percent composition of rust? So if you look closely, it did not give us any formulas, right? There's no formula there. So what do? You still follow exactly the same pattern. Just add up all the amounts to get the grand total. So iron is 1.26 grams, oxygen is 0.54 grams. All right. We'll treat the 1.8 as our grand total, and each of this for each element as our subtotal. All right. So then we go to step 2 now. You just divide again the subtotal by the grand total multiplied by 100. So percent Fe would be 1.26 divided by 1.8 times 100, you get 70%. And then oxygen would be 0.54 divided by 1.8 times 100, you get 30%. See it? Okay. Don't forget, guys, it's 0.54. You divide it first by 1.8, and then you multiply that answer by 100. All right. So don't forget, it's actually, this is how you put it in the calculator right there. Okay. So again, and it still adds up to 100 right here. Okay. So again, if there's no formula given, guys, just treat the amounts given as your subtotals, add them all up to get your grand total, and that will be what you need for your step 2. Okay. All right. Pause this video and let's do our next problem right here. Okay. All right. Very good. In the lab, a chemist analyzed a sample of methanol and found it was made out of 6.2 grams of carbon, 4.1 grams of hydrogen, and 15.9 grams of oxygen. What is the percent composition of each element? So again, there's no formula, so we just treat the given amounts as our subtotal. So carbon is 6.2 grams. Okay. Hydrogen is equals to 4.1 grams, and then oxygen is equals to 15.9 grams. Right. So let's add this all up. 6.2, okay, plus 4.1 plus 15.9 gives me 26.2, okay, grams. All right. Now we can calculate for the percent for each one. Again, just divide the subtotal by the grand total times 100. So for carbon, it's going to be 6.2 divided by 26.2 times 100. Okay, put this in a calculator and you should get 0.24 times 100 should give me 24%. Okay, how about percent hydrogen? This would be 4.1 over 26.2 times 100. Okay, 4.1 divided by is about 15.6%. And finally, percent O is equals to 15.9. Okay, or if you want, we could have gone to 16. It should have been 16. All right, it would have been a lot easier. Okay, divided by that times 100 gives me 60.7. Oh, yep, I should have just rounded off oxygen to 16. Okay, and this would have been a lot more easier. Anyways, okay, if you look at this one right here, and this is how you calculate the percent composition of a compound. All right. Hopefully these examples help you out before the quiz. And again, if you have any questions, just make sure that you attend tutorials or hit me up in the remind chat, and we'll figure out how to work out some problems with you all. All right. Thank you. Have a great day.